Today's lesson is on long and synthetic division of polynomials. We're going to start with long division, which means the numerator, 5x squared minus 17x minus 15, goes inside the house, and the denominator, the divisor, goes outside the house. And you may or may not recall that long division of polynomials requires taking the leading term, the first term of the divisor, and seeing what it needs in order to make the leading term of the numerator here. So if I multiplied x by 5x, I would get 5x squared. So then I multiply 5x by each of these and line it up under the correct term. So 5x squared minus 20x. I then subtract these. In order to subtract, each of the signs will change. Yeah. So these cancel out, which is what I set up to do. Then I get 3x, and I bring down my minus 15. And I start again. So what would I have to multiply x by to get 3x? I would have to multiply it by 3. So I multiply both terms by 3. So I get 3x minus 12. Then I subtract, which means the 3x becomes negative and the 12 becomes positive. Those cancel out. I get negative 3. I have nothing left to bring down. So that is my remainder. I could write it as remainder negative 3, and sometimes that's useful. I can't put a decimal point and drop a 0. That's not useful. But we could also write it as, since it's negative 3, minus 3 over x minus 4. So that would be the quotient. Let's try it again. So I have 2x to the third minus 6x squared minus 15x plus 5 divided by x squared minus 2x plus 1. And so what do I need to multiply x squared by to get 2x cubed? Multiply it by 2x. So everyone gets multiplied by 2x. I get 2x cubed minus 4x squared plus 2x. Everybody lined up under the term that they go with. I'm going to subtract. So that becomes negative, positive, and negative. The first terms cancel out. I get negative 2x squared minus 17x. And I bring down plus 5. And I start again. What does x squared need to be multiplied by to get negative 2x squared? Negative 2. So then everybody gets multiplied by negative 2. Negative 2x squared plus 4x minus 2. I'm going to subtract. So that would be positive, negative, positive. So let's cancel. I get negative 21x plus 7. I have nothing left to bring down, so this is my remainder. I could write it as plus negative 21x plus 7 over x squared minus 2x plus 1. Ultimately, I could write it as minus 21x minus 7, so I could take a negative out of here and put it there. Let's go again. 24x squared minus x minus 8 divided by 3x minus 2. So I have to multiply by 8x. I would get 24x squared minus 16x. I subtract. So I get 15x minus 8. I would have to multiply by 5. So I get 15x minus 10. I subtract. Remainder 2. So plus 2 over 3x minus 2. So that's long division. Some of the things that you might encounter if there's a missing term, either here or here. Lining up becomes critical, so you need to line up with the right terms, so be mindful of that. So now we're going to do synthetic division, which can only be done if you are dividing by a factor that looks like x plus or minus a. Okay, so it's a linear factor where the coefficient of x is a 1. So this is the only legal time you can do synthetic division. We're going to go back to one of the problems we did earlier and take a look at it if it's not like that. So here's some of the things about synthetic division. You pull the coefficients of the numerator, but you have to put them in order of powers. So the 9 would be first, minus 18 would be second, minus 16 would be third, and positive 32 would be last. Okay, and if there were any terms missing, like we have a third power, a second power, a first power, and a constant, if any one of those is missing, we would need to fill a 0 placeholder in order to do synthetic division. Because essentially this is saying we have an x cubed polynomial. Okay, what goes over here is the 0 that goes with that factor. So if x minus 2 is a factor, that means that the 0 is at positive 2. Okay, and synthetic division begins by bringing down, and then we multiply, and then we add, and then we multiply, and then we add, and then we multiply, and this is our remainder. In this case, our remainder is 0, which meant the division was even, and then we recollect. So if this was a third-degree polynomial, one layer of synthetic division would give us a second-degree polynomial. So 9x squared plus 0x minus 16. So that is our quotient. So let's try it again. Synthetic division. We have a 3, negative 16. Our x term is missing, so we're going to fill a 0. Negative 72. X minus 6 is our factor, so we're going to divide by the 0, 6. Bring down a 3. Multiply. Add. Multiply. Add. Multiply. Add. Again, a 0 remainder. That's a lot of what we're looking for when we do synthetic division, is a 0 remainder. This is, again, a third-degree polynomial, so this is a second-degree polynomial. Our quotient 3x squared plus 2x plus 12. Okay, so let's go back to some of our earlier problems and see if we could have done them synthetically. Okay, this particular problem could have been done synthetically. We would have had 5, that's our x squared term, negative 17, negative 15, and since x minus 4 is our factor, 4 is our 0, so we bring down a 5, 20, we add, we get 3, 12, we add, we get negative 3. So this was a second degree, so our quotient is a first degree, 5x plus 3, with a remainder of negative 3, so plus negative 3 over x minus 4. Same answer. We could not do synthetic division here because that is a second degree that we're trying to divide by, so that would have to be long division. Technically, we could not do synthetic division here because that's 3x minus 2. If you tried to do synthetic division, an interesting thing is going to happen. So we have 24 minus 1 minus 8 And we will be dividing by 2/3, right? The 0 that goes with that factor. So bring down 2/3 of 24 is, let's see, 8 comes to 16. Minus 1 would be 15. 2/3 of 15 is 10. So we have 2 as our remainder. So we would end up with, since this was a second degree, 24x plus 15 plus a remainder of 2 over 3x minus 2. And so the problem is we were supposed to get 8x plus 5, and we got 24x plus 15. So we ended up with a factor of 3 that we should not have. So there is some peril. As we go forward in the unit, we'll sort of explore how we could make this work for us. Here we actually did synthetic division. So give it a try.